Hi everyone, my name is Angela DeLeo and I did my science project on the effects of the starting temperature of water on the amount of time it takes water to reach boiling point. For this project, I created a hypothesis of will hot water reach boiling point faster than cold water? My outcome statement was that I predict that water at 90 degrees will reach boiling point faster than water at 60 degrees. I wanted to pick two different water temperatures that had a big enough contrast between the two of them that I can definitely survey the difference between hot and cold. I had to find my own definition of what hot water was and what cold water was. And when I was gathering my materials for the project, I realized I was going to need a thermometer for water. You need a liquid measuring cup, and you want to make sure for this project that it is on the metric system because you'll need 250 mLs of cold water per each trial and of hot water. To save time, I chose a small amount of water, which was only 250, and I used a small 1.5 quart saucepan to boil the water in on my stove. For the cold water, to get the water to reach 60 degrees, what I did was I filled a gallon of water, put it in the fridge for about a couple of hours, and then if it got below that temperature, I just let it sit out at room temperature until it reached my desired temperature. So as I started doing my trials, I realized that I was going to need the saucepan to cool off between each trials to make sure that that was not a variable that changed. I had to make sure that the saucepan was at room temperature for each trial. The content statement for this was the fact that this science experiment explores how when water boils, it's really the water molecules are speeding up as they are heated, and as those water molecules speed up, there's kinetic energy and it breaks apart the water molecules, and as they break apart they release hydrogen, which is what the water vapor is those water molecules being released into the air. And my hypothesis supported the content because I guessed that the hotter the water is to start with, the more kinetic energy you have to start with, meaning you'll reach that boiling point faster. So here is a picture of me measuring the temperature of water. I set my burner to high and I was waiting for it to reach boiling point. The manipulated variable in this project is the temperature of water to be boiled, which was the hot or cold water. The responding variable, which is the amount of time it takes for water to boil. And I had to have a lot of constants, meaning the room temperature had to be the same each time I had the trial take place. The amount of water to be boiled was exactly 250 milliliters each trial. The size of the pot remained consistent. The temperature of the burner was set to high at each trial, and the temperature of the pot had to remain at room temperature at the beginning of each trial. So I gathered all my materials and I got ready to perform my experiment. For the procedures, I listed off here how to start off. I started off with cold water first just because I thought that would be easier until I realized that I had to wait for the saucepan to cool, and I ended up doing about 3 trials each night until I got to the end. I started collecting my data and I realized that the data did support my hypothesis that hot water actually reached boiling point faster than cold water. With my data, you can see that the range was 95 between the longest that it took the hot water to boil and the shortest amount of time. And for the cold water was actually only 34. So the cold water temperatures didn't have as much of a range as the hot water, but the median amount of time it took for the hot water was only 116.5 seconds, whereas for cold water, it was 140 seconds. I created a graph so that way I could visualize my data. In my first two tests, it actually took the hot water longer to boil than the cold water, but in the remaining tests, it actually concluded that there was a big gap between the amount of time that it took the hot water and the cold water. On average, the difference between those two times was about 31.5 seconds. The average amount of time that it took the 90-degree water to boil was about 108.5 seconds, and for the cold water at 60 degrees, it took about 140 seconds to reach boiling point. So in conclusion, I did find that hot water reaches boiling point faster than cold water, and this is due to the heat transfer and how that makes the water molecules move faster, creating that kinetic energy. The hot water already has kinetic energy, which actually came from my hot water heater because the water was already starting to be heated up. So there was movement, it was already moving, and as it touched the burner and started to get higher, it could reach boiling point faster. That is why I believe the results came out the way that they did. And I think that scientists could use this information in their research of thermal energy, such as using steam, so like how they have steamboats and they have steam trains and turbines that use kinetic energy as a power source. It would be pertinent to understand that if we have access to hot water, such as something that's already dispensing water, it can make the water hotter from another energy source to release into whatever machine that they're going to use to create this, that would capture the most energy in the most efficient way possible, or the fastest way possible. So to know that hot water reaches boiling point faster than cold water can be very beneficial. I've created my narrative diary, which explores the steps that I took to complete this project. I hope you found this information useful, and I hope you all have a great night. Thank you.